Hi, everybody. Thank you so much for joining IFMA in our Wednesday webinar series. Today, with FM Systems, our partner, we are exploring the healthy building of tomorrow, leveraging smart buildings to realize decarbonation, not decarbonation, but decarbonization and occupant health goals. So we're going to explore the current understanding of healthy buildings and unpack the value and application of smart buildings. So I'm Kim Jackson, and I'm joining you from Houston, Texas. For those of you who are watching us live, please put in the chat where you're joining us from. We'd love to see who you are, where you are, and also any questions or comments that you have as we're going through our presentation today. Please know that we will address that towards the end of the presentation. So be sure to put that in there. We are watching for that. And joining us to make this presentation is Tyler Smith, Vice President of Global Life Cycle Solutions. Hi, Tyler.
Hello, Kim. Thank you.
All right. Have a great one.
All right, everyone. Good morning, good afternoon, good evening, wherever we're finding you in the world today. Really appreciate you joining today's discussion. I hope and expect that you'll find it a really good use of your time. And I look forward to engaging with you towards the end when we'll have time for Q&A, as Kim said. My name is Tyler Smith, and I lead a team at Johnson Controls called Global Lifecycle Solutions. I've been with Johnson Controls for over 20 years at this point, and I'm based in the US in Nashville, Tennessee. My team and I are responsible for delivering outcomes to our clients through innovative services, products, and smart building capabilities. And today we're going to be exploring the intersection of really all of those, and a topic that's really near and dear to my heart. And hopefully you'll hear the passion come out as we're talking about this today. And I hope that that passion inspires you to be equally passionate and engage with me during and after this discussion. We're going to be exploring several topics today. As you'll see here in a minute, we'll start with a re-baselining of some of the concepts that you've hopefully, likely heard over the last 5 years. And I've got 3 learning objectives for our time together today. If you don't hear anything else, if you don't learn anything else, if you pick up on these 3 things, then I will have accomplished my objective. I will have ensured that this was a good use of your time and your resources. So the first one is we'll talk a lot about this acronym, indoor air quality, IAQ, which we heard about during the pandemic. You're going to think, oh my gosh, Tyler, that was a COVID thing, a pandemic thing. Why are we talking about that? Hold on to that, and I'll convince you why it's more important now and will continue to be more important going forward than it ever was. The second thing that I commit to you that you will learn and take away from this is that there's this collection of really important outcomes that we can deliver in a building. The first one is improved IAQ. The second one is energy efficiency, also referred to as decarbonization. If you want to debate the difference between the two, let's do so in the Q&A at the end. And then the third, and one that I hope is going to cause you to pause and really think and really challenge yourself, is efficient space utilization. Efficient space utilization. Hybrid work, return to office, does that sound familiar? Well, we'll explore what efficient space utilization is and why it has an impact on these other outcomes that we'll talk about today. And then finally, we'll end our discussion, and you'll end your time learning some new things by me sharing some really neat market forces that are at play right now, some changes that are happening in the buildings space, specifically in smart buildings, and how those market forces are acting upon these 3 sets of outcomes, and what that's going to mean for facilities going forward, what that's going to mean for smart building technology going forward. I promise you it's going to be a great discussion, and you'll learn new things, I guarantee it. Okay, so keep these 3 learning objectives in mind. We're going to revisit them at the end, and I want you to tell me how we did. So, as I promised, we're going to start with some re-baselining of some phrases, some acronyms that likely you've picked up on over your time in the building space and facilities, definitely coming out of the pandemic a few years ago. The first is this concept of a healthy building, which predates the pandemic by decades. In fact, as long ago as anyone was in a building learning or doing their job, whether it's in an office or a factory, the environmental conditions in that building have an impact on that person, their engagement levels, their productivity, how well they learn, etc. And we're going to explore some of those outcomes here shortly. But I want to start first by reminding us of what I consider to be the best definition of a healthy building, and that's from our friends at Harvard, Joe Allen and his team, and the book that was published many years ago that's now, in my opinion, become industry standard when we think about what defines a healthy building and what outcomes are possible from a healthy building. And that team presents it in these 9 foundations: ventilation, air quality, thermal health, hot, cold, moisture, humidity, dusts, pests, safety and security, water quality, noise, lighting, and views. So it's the sum of those 9 characteristics of a building that individually and in combination contribute to whether or not we're creating a healthy indoor environment, an environment in which an occupant of that building is going to thrive. So for the purposes of this discussion and to achieve one of our learning objectives, I'm proposing taking these 9 definitions or these 9 foundations one step further and coding them based on whether or not each of those foundations impacts air quality, energy consumption, or both. Air quality, energy consumption, or both. And in doing so, as you can see on this page, make the point, draw the connection between a healthy building and a building that is energy efficient and in which we have good air quality. As you can see, there's a very, very clear connection. Very clear connection. So what I want to challenge you on, and this theme is going to be consistent throughout our discussion today, and I'd love to hear if how you react to this at the end. What I want to challenge you on is to broaden your understanding of what a healthy building is, and these concepts of air quality, indoor environmental quality, not just a COVID thing, not just a we're in the middle of a pandemic, oh my gosh, what do we do thing. It is a real and present opportunity for us in the building space, whatever you do and whatever I'm doing, to ensure that how we spend our time, what we develop, technologies that we put in buildings are healthy building technologies because of the wide-reaching impact operating a healthy building has on people and on the environment. So hold on to that. Really challenge yourself as we move forward here in the materials. So again, a bit of a refresher. When we talk about indoor air quality, IAQ specifically, what are the things that we care about? We can loosely categorize those into 3, as you see here. The first are gases, and that's exactly what you think it is. It could come from a person, could come as a product of combustion, like in a kitchen or other places where combustion takes place. It could be from chemicals. The second category here are contaminants, and those are typically a byproduct of some process, whether it's fire, such as particulates from smoke, particulates that are generated from a cooking process or cleaning. And then finally, on the far right, pathogens. Those could be respiratory aerosols. I I sing, I cough, I sneeze, I breathe, I talk. I'm generating respiratory aerosols, viruses, bacteria, mold, etc. You know what a pathogen is, thanks to what we've all gone through over the last 5 to 6 years. Okay, so again, grounding us when we talk about all these things, defining air quality in these 3 categories. Let's take that one step further. So remember those categories: gases, particles, pathogens. What I want to educate you on this page is, so what? So what can we do about it in a building? I propose 3 categories of actions that a typical building can take in order to combat those 3 categories: gases, particles, and pathogens. And I'm going to step down through these intentionally, but just to orient you on this page, I've got the 3 categories, I've got these 3 intervention measures, and then I've got how do we detect that it's actually working or that we need to do something under the sensor column, and then the relative energy consumption for each of these intervention measures. And we're gonna end with that column because, again, the purpose of this discussion is to demonstrate to you how all of these things are interrelated, how a healthy building and things that we can do to create a healthier building or healthier indoor environment. What is the impact to other objectives, other outcomes that you or your clients may care about, including energy efficiency? So the first intervention measure here is outside air ventilation. And I don't want to insult anyone's understanding of what that is, so just allow me to define that simply as bringing fresh air from the outside. Of course, there are some caveats to that. You or your clients, buildings that you're responsible for, may be in areas where the air outside of the building isn't the freshest. And so we may be limited in our ability to leverage outside air ventilation to offset certain pollutants, whether they're gases or pathogens. In the smart buildings world that I live in, there are some things that we can do to detect whether or not outside air ventilation is needed or possible or it's working. And 3 of those I've got listed here: carbon dioxide, CO2, total volatile organic compounds, TVOCs, or airflow, the speed of air, whether that's in the supply or in the return. It tends to be that outside air ventilation is the more expensive of the 3 intervention measures that I'll present to you today. So keep that in mind, and we'll revisit that when we get through these 3. The second, filtration. Hopefully you know what I mean when I say filter. You've likely got one in your home or your apartment or your flat, your condo, definitely in the place that you do business, where you send your kids to school. There are filters. We're going to oversimplify this and not focus on gas phase filters for this discussion, just standard mechanical filtration. And we employ, in the building space, we employ filtration to combat particles, pathogens to an extent. And there are certain things that we can use sensors to measure for, whether we need to employ more filtration, whether what we have in place is working. And that's traditionally PM, particulate matter levels. The number that you see after PM is the size of the bin of particles. We tend to find that, of course, every situation is slightly different, but we tend to find that on average, the relative energy consumption that would impact a building operator of that building's commitment to reducing energy consumption, that the relative energy consumption of filtration is the lowest. So as we work with our clients to make recommendations, are we bringing in an appropriate amount of outside air, and are we filtering air, whether it's outside air or air we're recirculating, the most effective way possible? And it's that filtration lever that we're really, really excited about because of the relatively low energy consumption. And finally, the third intervention measure that's most common in buildings, although I'll acknowledge that disinfection broadly as a category of things that we can do in buildings is still emerging. There are various types of disinfection technologies out there. The one that I'm most familiar with, that my company is most familiar with, is ultraviolet C, UVC disinfection. Many applications of UVC. We'll talk a little bit about some emerging applications of UVC at the end, whether they're back at an air moving device called an air handler, they're in ductwork somewhere above a ceiling, or in a space. There's some neat ways that we can apply UVC technology. We learned a lot about disinfection thanks to the pandemic. We're primarily employing it still these days to combat pathogens, not just SARS-CoV-2, but others. Ways that we can sense whether or not we need to employ disinfection or whether it's working are also still emerging. Historically, we've had to send samples off to labs to confirm. And this one falls right in the middle of these three intervention measures when it comes to relative energy consumption. So you can see, we zoom out a little bit and we move our focus to the right of this page, that we have options. We have options, those of us that are responsible for buildings and controlling the airflow in buildings, sensing in buildings. We've got options available to us when we think about delivering a healthy indoor environment with a focus on air quality. And it's important that you make a decision that balances the outcomes that you want to achieve. At one end of the spectrum, you could have a building, I don't know if any buildings like this these days, but in which energy consumption is not a concern. We're going to throw every single intervention measure that we have at it, assuming that an outcome that they value is the cleanest air possible. At the complete opposite end of the spectrum is, oh my gosh, I can't spend a single dollar more on energy consumption, and I'm willing to let the other things float, literally and figuratively. So keep these in mind as we continue to explore the material together, and let's really be intentional at finding that intersection point on healthy indoor environments and energy consumption. In so doing, I propose this Venn diagram that you see on the page, in which a definition of a healthy building that I'm really excited about going forward exists at that intersection point. We've got a Venn diagram here of energy efficiency / decarbonization, optimized indoor air quality. For the purposes of this discussion, I'm really zeroing in on IAQ, indoor air quality, although I acknowledge that it's broader than that, broader than just air. We've got other things that impact environmental quality. Think to our 9 foundations at the top of the discussion. And then finally, this third one of efficient space utilization. And I'll say a couple of things about this now. I want you to chew on it, and we'll talk a bit more about it later in the discussion. Efficient space utilization is important. It will continue to be important as you, as your clients, explore what is the ideal footprint for my operations going forward, whether I operate commercial real estate or school or anything in between. That is a real and present discussion that's happening in many boardrooms and many meetings. Where are my people? Am I enabling their working from home or some hybrid model? What are they doing? Am I going to ask them to come back to the office? How many people am I going to hire going forward? What's the impact of AI on the optimal number of people in my organization or in my building going forward? So on and so forth. The answers to those questions, the outcome of that debate, and obviously it's going to be dynamic going forward, is an input into, well, what amount of energy is required to keep that building safe and comfortable, to keep it healthy? What if I'm wasting energy conditioning a space or cleaning the air being delivered to a space because I don't have any people in that wing of the building and I don't realize it, and I haven't made any decisions yet on what I'm going to do about that wing, but I'm letting people work from there? and it accommodates 100, but there's that one dude that likes to work from that conference room, and we're basically conditioning that wing because he wants to work from there. So understanding the optimal amount of real estate footprint, uh, the who you're asking to come back in, what they're doing when they're in your facility, where you're letting them go, leveraging sensors and smart buildings to take the output of all that into decisions that are made on how we operate that building, so critical going forward. So I propose to you an enhanced definition of a healthy building that builds on the foundations that we discussed at the top and layers in additional, very closely related and correlated outcomes that are driving decisions in the buildings market forward for many, many, many years to come. So again, keep this Venn diagram in your brain as we move forward. So let's talk a bit about the financial justification of everything that we've explored over the last 20 minutes or so. So it makes sense on paper. Of course, we want to operate a comfortable space. Of course, we want to deliver a healthy indoor environment. Why wouldn't we? Who in their right mind would commit to delivering an unhealthy environment? Whether they know it or not is another discussion. But as we know these days, and increasingly going forward, a decision to invest in any of these interventions, any sensors or smart building technology more broadly, those decisions are traditionally capital intensive decisions. And those capital investments need to stack up and hold water when compared against other capital decisions that an organization needs to make. We're not in 4 to 5 years ago where things that I've been talking about, like enhanced filtration, are gonna sail through approvals, especially with a CFO who's monitoring cash flow. We're not in that time anymore. So these are capital decisions that need to return better than other potential capital decisions that can be made. And so we have to justify them. So I'm going to step you through over the next few pages here some ways that we can think about that justification. And I'm going to present to you a concept. There's a couple of variants of this concept that are out there. You may have heard, or we may even have some friends from JLL on the call with us. A 330-300 principle, 330-300 principle that they introduced 8 to 10 years ago or so in a white paper that posits that there are buckets of cost, high-level buckets of cost, when you think about operating a building. You've got rent or you've got energy costs as the lowest bucket, traditionally $3 per square foot, and I'm going to use dollars and square feet here for this discussion here for a second. You've got rental or lease costs, traditionally $30 a square foot, give or take, depending on the market that you're in, of course. And then you've got staff costs, and that's salaries, that's benefits, it's everything that we think about when it comes to people in the building. $300 per square foot on average, 300. What I'm presenting here on the left is a variant of that turns those dollars and square feet into percentages, a little bit easier to think about. And we have our friends at the World Green Building Council, World GBC, to thank. 1% energy, 9% rental, 90% staff costs in the form of salaries and benefits. So yes, I'm generalizing. Yes, I understand that as we move from different industries, across different industries rather, or locations in the world, energy costs are going to fluctuate, people costs are going to fluctuate. Go on this journey with me, and let's at least agree that there is, roughly an order of magnitude difference between or among those three cost buckets. So what does that mean? Why should you care? Shifting you and your eyes to the right side of this page. When we think about the people in that building, in that largest bucket of cost, and what we can do to impact something as simple as their productivity. They're doing their thing, making that widget, performing that task in an office. And we think about the intervention measures that we talked about before and the benefits, which we'll explore also in subsequent slides, of operating a healthier building. We can then start comparing an improvement in their productivity to a corresponding offset of rent or energy costs. Let me give you a couple of examples. I've got the three here in this table. The first is a 1% increase in productivity. So I've done something to the indoor environment of that facility that has resulted in a 1% increase in productivity. Because of that relationship, because of the orders of magnitude difference in those cost buckets, a 1% increase in productivity can roughly offset a 90% increase in energy costs. That's huge, absolutely huge. Give you another example. 1% increase in productivity, roughly offset a 10% increase in rent or lease costs. That's huge, absolutely huge. And that's just 1 percentage point. 1 percentage point, excuse me. So keep that in mind. Primarily the relationship among decisions that we can make as we operate a building, the impact that those decisions have on the people in that building, health, wellness, and productivity of those people, and what that means as far as other commitments, other market forces that are acting upon the operations of that facility. And I'll give you a few other proof points and statistics to think about that drive the importance of that relationship home even further. It's likely that you have seen some statistics about the benefit of operating a healthy building. It may have been a few years, but allow me to remind you of some of the things that have come up in research and in reality time and time again. The first, on the top left, healthy buildings, according to our friends at MIT, command a 4 to 7% premium in per square foot lease rates. You make investments in a healthier building, those investments pay back in the form of an end user being willing to pay more to spend their time or to ask their people to come into that space. I'm going to come back to the one on the bottom left because it's the one I'm most proud of. We'll end the page with that one. Harvard published some really compelling statistics on healthier work environments leading to reductions in sick leave, cognitive tasks, performance increase of roughly 10 percentage points when we're working in a well-ventilated office. You know what I mean when I say well-ventilated. You can feel it, you can smell it. I checked out of a hotel this morning actually, and I could tell that they were in economizer mode. Beautiful day here in Chicago, nice cool air outside, and they were taking full advantage of that by ventilating the hotel very, very well. And then the relationship among HVAC systems, energy consumption associated with HVAC systems, it's a huge number. If you haven't heard the statistic, up to 40% of energy in the average building goes towards HVAC systems. And so much opportunity that exists, and a topic for a future webinar when we talk about things that we can do to improve the HVAC system energy consumption in buildings. I want to reorient you back down to the bottom left of this page. My team has put some work into, and I know that there are other similar proof points out there, distilling all of this research down into an actionable estimate. And that estimate is as follows. Companies, building operators, et cetera, that prioritize improved air quality can expect a bottom line, so we're talking about profitability here, a bottom line impact of roughly $800 per employee per year. $800 per employee per year. I've seen higher estimates. So think back to our discussion a few minutes ago about capital investments and how I've got to build a business case. I want to go enhance the filtration in my building because I'm committed to delivering a healthy indoor environment, and that's going to cost X. Or I am going to make a case to increase the amount of fresh air ventilation in my operations of this building, and that's going to cost me X. And I need to go make a case for that capital investment. This rule of thumb helps. This rule of thumb helps you build that business case of I invest X, I should expect Y return, and my payback is going to be roughly Z. High level here, invest X, Y return, payback is going to be Z. And that simple math with this rule of thumb can help make that decision or drive that investment towards an investment in a healthier building when we're stacking up against other things that we have to invest our capital in. Okay. I'm going to keep us moving here. We've shifted from some proof points, some expected returns. How do we think about the intersection of these sets of outcomes, energy efficiency, air quality, and efficient space utilization? And I want to talk for a minute about the role of smart building technology. Smart building technology. Again, catering to the average listener here, allow me to take you on a journey here of what do we mean when we say smart building technology? And step you through left to right on this great oversimplification of what we mean when we say smart building technology, culminating in some of the outcomes that a smart building can deliver on the far right. On the left, I'm presenting a collection of things that we can sense for that are important inputs and decisions that we can make as we operate buildings. Got them loosely categorized here. Green is things outside of the building. What's the weather and climate? What's the outdoor air conditions? Just like I said, we can sense for things like particulate matter inside of buildings. We do the same thing outside of buildings. In yellow, got some maybe more common things that we're sensing for, more common in buildings, more common in traditional air quality sensors and traditional just standard smart building sensors. Temperature, of course, relative humidity, of course, carbon dioxide, CO2, the various levels of particulate matter that we're able to sense for, and kind of a rolled up sum of VOCs that are in the air, this total volatile organic compound measure, TVOC. A couple other things that are fun and emerging. Occupancy, how many people are in the space? We talked about why that's important, remember? Location, where are people? I've got 50 people, but where are they? Talked a lot about energy in light blue. And this really fun one down on the bottom left that we'll pick up at the end of our discussion of the microbiome of the building. Some hopefully emerging capabilities that we'll see in the buildings industry and our ability to sense for the microbiome of a building. So we understand all of those variables thanks to sensors. It doesn't matter whose sensors they are for the purposes of this discussion. We have sensors that are placed on walls and above ceilings and ductwork, other locations maybe outside of a building, or we're using virtual sensors. It could be data that we're getting from a weather station, and we're ingesting that back in a smart building system through some type of cloud-based interface. And then a smart building system then takes all the input from various sensors and does something with that data, transforms that data somehow. And this is this concept of taking inputs from sensors, doing something with the data, and then making decisions based off of the transformations that we do, the analysis that we do is not new. We've been doing this smart buildings industry for decades. Of course, the technologies that we employ to make that happen have definitely evolved over time. And the things that we can do with the data, the output that we can do has, of course, evolved over time. Some really neat things that we can do with AI. I'll talk about that in a minute. More traditional things like generating reports, creating cool dashboards or kiosks. I walk into a building, I look to my right, I see this nice pretty screen, and it talks about how safe, healthy, energy efficient, the impact of that energy efficiency commitment on the environment, et cetera, I can expect as I spend time in this building. And then, of course, the most important thing is number 3 there at the bottom, smart building control. We then make some decisions. We open and close things. We turn things on and off. That then becomes an input back into those sensors, and we close the loop. We operate that building. However, the most important thing, the most visible thing, and what we're actually should be making our decisions on are the outcomes that all of that enables, unlocks for building owner, building operator, stakeholders of that building. I'm more productive. We see a reduction in absenteeism. Attrition rates decline. Test scores, if I'm in a school, improve. Of course, carbon emissions improve. I'm utilizing space more efficiently, and my infection risk has decreased. We talked a bit about on previous pages the interaction among those outcomes, and I expect we're going to have some questions on that towards the end, and we can explore that further at that time. So great oversimplification, but hopefully a nice 3 or 4 minute introduction or reintroduction to you on how sensors work, how smart buildings work, and then what we should all be focused on, which is, so what? So what do we get when we do all this? What can we expect in a building? Talk for a second about a quick case study, a real estate developer in Southeast Asia who was concerned, and we're seeing this more and more with what they thought were competing sets of outcomes. I can operate I can operate this building in a more energy efficient way, or I can employ these intervention measures, Tyler, that you presented at the top of the deck. I can operate this building healthier. I can improve indoor air quality, but I can't do both. I can't do both. And this real estate developer employed smart building technology, the sensors that we talked about on the previous page, and a digital platform to first measure and drive accountability and visibility to those what they thought may have been competing sets of outcomes. Employed some of the capabilities in that smart building technology, including AI, and were able to deliver both. Able to deliver both a healthy building, one with improved air quality, and are well on their way towards delivering on the energy and emissions reductions targets that they have set for this building. Really, really simple yet compelling proof point of someone that found once they put the right sensors in, put the right technology in, they were able to make it happen. And maybe most importantly, that those two sets of outcomes were not necessarily in conflict with each other. Now let's talk about how we can make that happen thanks to technology. So there's this new thing that you haven't heard of called artificial intelligence, or AI. And again, a topic for a future webinar. And so we'll just kind of fly by it here and talk about one use case, one really cool way that we can employ AI in the operation of buildings. And that is training models to help us pick an optimal operating point that balances certain variables that may otherwise be in conflict. And I'll direct your attention to what appears to be random collection of dots on the graph on the far right of this page. But as you can see, we've got on the y-axis on the left, energy costs, and on the bottom x-axis, we've got transmission risk. We're looking at infection transmission here on this plot. And we can, using data, historical data, train models to understand the relationship between I'm operating here, what's the infection risk at this operating point, and what's the energy I'm spending at this point, and here, and here, and here, and here, and here, and build a curve that we can then use to recommend decisions on how to operate that building, or increasingly going forward, autonomously make decisions in real time based on finding that delicate balance point. So I can say, hey, smart building system, I really want to balance the risk of infections, whether it's influenza or otherwise in my building, and energy consumption, because both are important to me. I want you to find that optimal operating point, and I want you to operate this building on my behalf accordingly. Or you can say, just like we explored at the top of the discussion, actually care more about energy efficiency. I've made some really aggressive commitments. And for the time being, I'd like to index slightly more towards operating my building in a more efficient way. Can you help me find that operating point? And so on and so forth. That's real, that's present, that's capabilities in smart building technologies today. So on our journey here, think back to our objectives at the top of the call. We've talked a bit about some baseline understanding, rebaselining your understanding of healthy buildings and air quality. We've talked about sensors and smart buildings. We've talked financials and ROI and things like that. I want to, we've got a few more slides left. Start bringing us home here on why knowing where people are and how many people are there in buildings is important to us. And I introduced this, and I'm going to double down on this example of the worst thing that we can do is clean the air in a portion of a building that's not being used, or in which the occupancy is not at design occupancy. That relationship of knowing where people are, cleaning and conditioning the air in the right way, and spending the right amount of energy on doing so is so critical. So critical. That's that Venn diagram that I presented. That's what I'm positing is the current and future definition of a healthy building, where we're doing all three of those really, really well. And we have smart building capabilities that are present today to thank for our being able to sense for, count people, understand where they are. And there's many, many ways that we can do this. Understand where they are and how many people are there, and use that as an input into controlling that building. Many proof points of where this has happened. I'm presenting here at an acute care hospital in the southwest region of the US. Had all kinds of questions as they were a couple of years ago now, considering what their hybrid work strategy was going to be. Decisions like we talked about on rationalizing real estate footprints, and identified opportunities to collect data using the sensors that I'm referencing to track people that were coming back to administrative sites. They used this data as an input into not only decisions they were making real time and where they want people to be sitting, but also as an opportunity to unlock additional insights on energy consumption of those administrative sites and on the resulting air quality needs, such that those sites were as healthy as possible. So as we finish up here, and I would love for you to challenge yourself, really reflect on what we've talked about for the last 40 or so minutes here. Any questions that you have, please share them with us in the chat, and we'll get to them time permitting. I want to share with you, you can tell that this is something that I think about every day. It's a big piece of my responsibilities. I am most excited about some really cool things happening in 4 categories, 4 areas of smart buildings, smart and healthy buildings. I'd like to leave you with them, and if you'd like to discuss them more, please put any questions in the chat. I'll also provide my contact information, and we can have a healthy, constructive debate some other time. The first is in building codes. You say, Tyler, this is all well and good, but we know full well that we're not going to reach the potential of everything that you're talking about until such time it's required by code. And to an extent, I agree. There is going to be a certain segment of buildings, of facilities out there that don't care but can't afford to, and are not necessarily going to be the adopters, whether they're early or mid-stage adopters of the technologies and smart building strategies that we've been talking about. And it's not until such time that codes reflect some of these best practices, that we're going to see much wider adoption. So thankfully, we have some really active discussions with code bodies, groups, including my company, to lobby for these best practices to be adopted in building codes. Once they're adopted in building codes, some number of years pass, unfortunately, they're adopted at the state, local, and municipal levels. And that new building that gets built or substantially renovated references that code, and we're going to see more and more an increase in adoption of these strategies and these technologies. One that we're closely monitoring right now is a higher level of filtration referenced by the International Mechanical Code. Talking now, moving to the right, more about disinfection. Recall that we explored that as one of the neat things that we can do to reduce the spread of pathogens in buildings and keep people healthy and productive. Some emerging capabilities here, been around for actually some years, still seeing some tests here before we see wide adoption on UVC directly in a space. So imagine a future where you walk into the lobby of a hospital, you have visible light and you have UV light that are both shining, air quotes, shining down into a space, providing simultaneous surface and air distribution. It's possible through a technology called far UV, which operates at a certain wavelength of UV light that is safer to skin and eyeballs, things that we're worried about burning if we come into a direct contact with other wavelengths of UV light. So for those that are interested in this, I encourage you to do some research and be on the lookout for some really neat innovation that's happening in UVC disinfection. On the bottom left here, I've talked about codes. I want to explore a little bit more about other things that we're seeing globally, led by the EU, the European Union, and a really neat law, an enhancement to an existing law called the Energy Performance of Buildings Directive, EPBD, that was recast in the last 12 months. As buildings in the EU go on their journey towards net zero, it's going to be required that they also include indoor environmental quality, including indoor air quality, on that journey. It is currently being adopted in member countries as we speak, and we expect for it to be a model of what's possible as we drive adoption at a macro level, not just at a local level, but at a macro level. And I get that not every government or collection of governments is like the European Union, but we have them to thank for really demonstrating a firm commitment to what otherwise may be seen as competing sets of outcomes: a net zero building and a healthy building. Net zero building and a healthy building, both possible. And finally, leaving you with a really neat and emerging set of capabilities around biosensing. I mentioned that on a previous page. There's some fun research that's being funded by the US government, specifically the ARPA-H program, to develop biosensing capabilities. So imagine a potential future in which you've walked into that same hospital, into the lobby, you've got some great UV light, and somewhere in that hospital, you also have biosensing. It's happening in real time, detecting for the presence of pathogens, viruses, bacteria, and then helping us close that loop. Remember, closing the loop in how we operate a building based on the presence of those things, those pathogens, because we were able to sense for them. That is the future that we're all hopeful for, that we're all marching towards. Really, really exciting innovation happening here. Hopefully I've gotten you excited as well. So with that, we've got roughly 10 minutes left, in which I'll recap the commitments that I made to you, that this was going to be a good hour of your time, and then we'll shift into answering as many questions as we can. So again, at the top, I challenged you to think about certain things differently, I'm going to challenge you again on how investing in people can pay back, investing in health can pay back. I'm reminded of our friends at the International Well Building Institute and the Investing in Health Pays Back campaign. If you're interested in learning more about additional data that IWBI has gathered, please go visit their site. And also remember the importance of above code standards. I talked a lot about building codes, the importance of above code standards like well, absolutely critical going forward also. Secondly here, your call to action. When you think about investing in smart buildings, challenge yourself to think broadly about how you can deliver multiple sets of what otherwise may be considered, thought to be outcomes that are in conflict with each other. Energy efficiency, air quality or indoor environmental quality, and of course, space outcomes. And then finally, think back to where I said innovation was happening, where we're seeing some cool advancements in codes and standards and laws. And let's get out in front of that stuff. Let's use it. Let's encourage ourselves to be early adopters. Let's think about the return on investment and the business case behind doing so. And hopefully, you'll arrive at the conclusion, like I have, that operating a healthier building, especially with this broader definition going forward, is now more important now and going forward than it ever was. So with that, I'm going to share my contact information. So take a screen grab of this or write it down, reach out to me if you'd like to continue the discussion. And we're going to shift into answering some questions that have come up in the chat. The first one here is around the balance that we've been talking about. And Mohammed's question, I'll just read it off to everybody, and I think we'll flash it on the screen here. How can we effectively balance the trade-off between energy efficiency and optimized indoor air quality, given that enhanced ventilation often increases energy consumption? And this is a pretty common question. So again, the concept here is we can, when possible, bring in fresher air from outside of a building, inside the building, and in doing so, impact the indoor environment and the people that are in that building. However, depending on where you are in the world especially, that air may be hot, may be really cold, it may be humid, it may be really dry, it may have high particulate matter count, or other pollutants that we're concerned about. It may be right next to an interstate or a highway. So of course, there are some things that we need to be mindful of as we consider our ventilation strategies. But generally, bringing in air from the outside, we've got to do something with that air before we can distribute it into the space. And that doing something with it traditionally requires consuming energy. And so Mohammed's question is, so shouldn't we assume then that across the board, ventilating air or bringing in more air from the outside is going to cost us, is going to have some type of energy penalty associated with it? In some cases, it will. In some cases, it will. But what we typically find, Mohammed, is that no building is operating perfectly today. No building is operating perfectly today. I had on one of my statistics slides the amount of energy consumed in HVAC systems being roughly 40%. Studies showing that the average building is operating very energy inefficiently, and that there are certain things that we can do, certain relatively simple things that we can do to improve it. So what I'm proposing, Mohammed, is a future in which we're considering improving improving ventilation alongside doing other things to improve the energy consumption of a building, and those offsetting hopefully for the better. And we find this future in which we have improved the energy efficiency of the building and improved the health, wellness, and productivity of people in it. It can be a tricky one, I admit, and we don't have enough time to go through and dive into this one deeply, but I want you to believe me. I want you to believe me that that future is that present is possible today, but it requires our ability to sense for certain things. We need sensors. We need some type of smart building technology so that we can make trade-off decisions, et cetera, et cetera. All right, great question. Thank you. I'm going to move on to another one here. What challenges do you see with clients being willing to share data for AI to generate insights or to automate decisions? Data protection is a big concern. Of course, that concern is greater or less depending on where you are in the world. This is a big one. And again, another cool hour-long webinar topic for the future. The concept here is that in order to generate insights, to make decisions, whether that's happening through a traditional smart building system in which we've programmed kind of if this, then that, I sense this, I do this, or we've trained an AI to automate some or all of those decisions for us. That data needs to be transformed somehow, needs to be transmitted and transformed somehow. So suffice it to say that yes, in some cases, data may need to leave a building, or we may need to bring in additional data from some cloud connection and API in. And so we've got this set of concerns around, I've got data leaving my building. I'm not comfortable with that. Or we're using potentially proprietary or sensitive data to make decisions or train an AI. The big concern, I get it. Some things to think about are what decisions we can make local to that building, in which data actually isn't leaving the site, versus others in which data would need to leave the site. And I want to assuage fears that there is a future in which we can accomplish, or a present in some cases, in which we can accomplish these objectives without data having to leave the site. And we'll leave that question there for now. I want to get another one really quickly, and then we'll pause and close down the call. I want to finish with a how is energy efficiency evolving in today's smart buildings? So this will be the last one, 30 seconds or so, and then we'll finish up. How's energy efficiency evolving? Well, you don't have to look too far to see concerns that are being raised about the impact of advancements in AI and data centers and the energy and water consumption associated with data centers, to see that energy efficiency in buildings is more important now and will continue to be more important than it ever has been. So as you think, those that are curious to learn more about where energy efficiency is headed, we've got some things happening at a policy level. We've got some things happening on the innovation front, data centers and AI potentially being a headwind to our overall carbon emission reduction goals. It's not all bad. There's some great opportunities ahead of us, some ways to drive efficiency into how we operate data centers, and I'll leave that as a cliffhanger for you to explore on your own. So with that, I want to thank you very much for your time and your engagement today. Hopefully you learned something, and I look forward to engaging with you outside of this call. Wishing everyone a great day.